Okay, so this one I want to go over because here is a glaring hint. These are really good multiple choice questions that you should be able to do relatively quickly. So this problem says a bike wheel rotates uniformly through 2 revolutions in 4 seconds. What is the linear speed of a point 0.10 meters from the center of the wheel? Okay, so first let's draw a picture. Peanut gallery. Actually, they can't hear you. Okay, so remember when we were talking in class and we said, so what happens if I'm here versus if I'm here? Is this spot going to rotate faster or slower than that spot? And we decided, actually, let's do it like this. We decided that because the entire wheel is going to have a certain rotation, so it's only going to do one rotation, and both of these spots are going to experience that rotation, that the further out you go, the faster your linear velocity is. And this just kind of makes sense because this guy just doesn't have as far to go to get around that one complete rotation, and this guy has further to go. So the further out you go, the higher the linear velocity. And then we can think in terms of then how do we define that? So we have our linear velocity is our omega, okay, so that's just how fast the darn thing's rotating, times r. And that's just the distance away from the center. Cool. So now I was hoping that we have this kind of deeply embedded in our brains. We have 2 revolutions in 4 seconds. Okay. So if I have 2 revolutions in 4 seconds, if I want this to be in terms of radians per second, which is our measure of distance rotating around, then I need to turn this revolutions into radians to get our omega. So I have my 2 pi radians per 1 revolution. Cool. So now let's simplify this. I have 4, so these little guys are going to go away, and I'm going to get omega equals pi radians per second. We have that. Cool. Yeah, but we are also given our distance from the center, so 0.10. And when we're thinking about v, and we say, okay, so I need r, so this is just omega, or v equals pi radians. Can you see that? Yep. Radians per second times our r, which is 0.1 meters. And let me just do that. So my 3.14 is going to become something like 0.314 meters per second. And this is where I was saying we just kind of tend to dispose of that radians once we move into meters. This just becomes just this kind of unitless quantity. But it is important to hold on to until we get to here. And you'll see with our angular rotation, we do hold on to the radians per second, but magic voodoo, it goes away here. And I think of a good way to explain why that is, but for now, just know. So real quick then, if I was doing this on a test, I would look at this and I would remember, okay, so distance away, omega r, that omega is, I need to turn that into my radians per second. Real quick look, and things cancel out, so I'm in pi. So pi times 0.1, and I didn't even need to whip out a calculator. I'm just shifting this over by 1. I look on my multiple choice options, and bada bing, bada boom, there it is, and I'm happy. So that is a quick and dirty one.